Yeah,
Yeah.
and we may not know exactly the specific genes, but how much of the disparity can be chalked up to genetics in terms of um, the
Yeah,
wide ranging abilities we see in sport?
it depends on the metric you're looking at. So something like height.
Mm.
Okay, that is
Yeah.
pretty much 99%, inheritance. There's not a lot you can do training wise. The only thing you can really do to height is, of course, nutritionally.
Yeah.
If you're failure to thrive, you may not reach what you had the genetic potential for, and the opposite if you were given excessive food intake like we have now. Like in general, people are getting the human species is getting taller, better things like that. Okay, so but you're talking, I don't know what the number is, 95% genetic or something.
Right.
The other end of the spectrum, something like that's, I mean, for the rest of it's 20% genetic. It's 80% training. Several studies we published, and I could certainly go into detail of one of them if you want, but
Yeah.
we typically would say 50% genetics, 50% lifestyle, but I would argue that
Right.
for most metrics people care about, it's more like 25% genetics, 75% what we call exposome, which is
Wow.
everything else besides genetics. So sport performance is, I mean, depends on what you're looking at. Skill is a different thing, and I don't think we're anywhere near understanding skill. So what I mean by that is like fine motor skill. So while, for example, genetics might predict 25% of your squat strength, I don't know what percentage it predicts of, say, your golf swing, or can you shoot a basketball well? Not jump well, not play defense well. Can you shoot it? So those fine motor skills. It's just not my area, so I don't have any clue what of that is determined by genetics. That might be different. So, like I said, it depends on what sort of metric you're looking at.
Yeah. So, I mean, you're saying there that you think that it's kind of 25% is down to genetics, 75% essentially nurture, what you've done, how hard you've trained, all of these sorts of things. So does that mean that is there some scope of understanding of if we were to have these genetically edited babies, how much of an improvement or magnitude can we actually see from that? And is that at a point where there wouldn't actually be that much of an improvement because the guys who make it to the top already have that 25% and the 75%, and it's more that you can just control who it is rather than actually seeing an increase in performance?
Well, the increase in performance would be large.
It would.
Because think about it this way. What separates first through fifth place, on a podium, you're talking usually 5%.
Yeah.
And you could certainly get within that range of changing so genetically. But having said that, it would be a blend, of course, right? So you would have people on the far end which are genetically optimized and that train really hard. And those people are just going to be untouchable. You have some people that are going to be in the middle. Some of them either had the genes but didn't train as properly or as hard, could just be proper training. Or some people who didn't have great gene edited but inherited good genes and trained great. But those people would never reach the far end of the spectrum people. And the people on the other end, which are either born shit, didn't train shit, or given really good genes and didn't train at all. So you would always have a blend, but of course the average would float to the end where those people would be untouchable. And they would, of course, eventually over time, we will figure out what needs to be moved for what marker, and you would see a shattering of everything.
Yeah. Now, one of the things that I'm particularly excited to talk about is you've done a lot of research recently I think you released it within the last couple of weeks. You went to the World Championships. You tested a few high-level athletes. Is that available to talk about?
It's not really.
No?
Literally
Okay.
This morning, as soon as I can stop talking to you two jerks, we submitted it for publication. It is the way that it works is the first round of revisions have come back to me, and it's been a couple of weeks. I've been working on those, and I will finish those up within an hour or so of this conversation and submit those back in. And from there, it could be a matter of 15 minutes to another couple of months before we hear back that if it's accepted.
Right.
It could be another round of revisions. Sometimes it's accepted immediately. So we can't talk about those two things in too much detail. We could certainly talk about it globally, which is
let's do that.
Yeah, we were fortunate to Weightlifting World Championships and the American Open, which is the I don't remember if it was the finals or the Series 3 or something. The second biggest.
Yeah, AO3 was pretty big. Yeah.
Yeah, it meets, if you will, in the States.
Yeah.
It's not national championships, but it's pretty good. It happened to be both hosted in the same event center about 5 miles from our laboratory.
Nice.
So we tried like hell the year before when it was in Houston to try to get biopsies and to study some of the athletes down there. It didn't work, and so then we got lucky. I don't really know if you guys remember the story of how World Championships came to Anaheim.
Yeah.
So we got so lucky, and I was like, we have to do this. And we didn't have any funding or anything, but I was just like, I don't care. We can't let this opportunity go. So we were able to collect data, and by that I mean muscle biopsies on 21 Americans, 15 females, and 6 males. And these are individuals that were either on the world. This is all Americans, either on our world team or on the Rio Olympic team, or were top 5 or higher finisher in the American Open. So we tried to get those that were as selected. So it enabled us to actually create 3 categories, which were world-class females. And so these were, again, females that were on the world or previous Olympic team, but that were competing in those events. National caliber females is what we called it. So those that have been national champions, things like that, but not on the Olympic team, on the world team. And then national caliber men. And we saw some very interesting things that separated all of those groups from the level of the muscle fiber type. And so this is what I was kind of referring to earlier. Like it could separate groups a little bit. There didn't seem to be as big of a separation between the 2 national caliber categories, but between the world caliber and the national,
really,
there definitely was. And so something is different about these folks, and that could be a combination of talent, or those in the world category were also had about 2.5 times the training and competition age.
Okay. So, I always thought, so I did a sports science degree and learned not a whole lot, if I'm honest. But
Neither did I.
I think that
I'll make it worse. I got 3 of them. 3 of those. I still don't remember much in any of them.
You know something. But one of the things that I really thought, and I think that a lot of people listening think, is that the biggest thing that separates myself from Ilya Ilyin is the fact that he's got different muscle fiber types than me. And it's like, listening to you talk now, you kind of realize actually that's not the thing that separates us. I can train to get perhaps close to the certain number of same kind of disparity or whatever of muscle fiber type. So what is it that separates us genetically? If it's not that.
So if you look at what produces human movement, it's 3 things. Okay, and you could have you can see a change in performance with a change in any of these 3 or a combination of these 3. And so you simply can't isolate one and say that's the problem. So let's say, for example, you 2 have the exact same fiber type profile. Okay, well, to make human movement happen, the first step is you have to have a signal from either the brain or the spinal cord, so the brain stem, that has to be sent out to muscle. That tells muscle to contract. Muscle contracts, pulls on a tendon, which is a very important piece here. That tendon makes the bone move. Muscle does not make the bone move. Muscle makes tendon move. Tendon transfers it over. So most people are aware of the neurological thing, so that would be number 1. But let's say for somehow you are exactly the same neurologically, it's exactly the same muscle. If, for example, your muscles lie at a different angle relative to the bone, that changes mechanical advantage or disadvantage. When you go up or down in one of them, you typically gain speed, but you lose range of motion.
Right.
Or force, right? So force and range of motion and speed are all intricately related, and they're inverse. So when one goes up, the other goes down. Mechanical advantage, biomechanics, and let's just say technique is the exact same. Okay, like we'll just give you all that in training, but like all those other things, just looking internally at the bottom. It could be simply his connective tissue is better at transferring that force.
Yeah.
Could be a biomechanical thing. It could be properties inherent to the connective tissue themselves. You could line those connective tissue up, have the exact same origin insertion place, but the tensile strength is better. They're stiffer. They're more pliable, or they're non-pliable. Things like that. So, or it could be most likely a combination of all the things. Most likely, he has different fiber type. His fibers are bigger. He's neurologically more tuned. His connective tissue is better. His biomechanics are better. He's stronger mentally, and he has better technique.
You just had to throw that in, didn't you?
I had to get it. But there's even things that are inherent to the muscle, too. So not every fast-twitch fiber can produce the same amount of force.
Right.
Even independent of size. So even if we equate for size, They're connected. They're contractile properties inherent to the actual muscle tissue themselves that differentiate us. And I can give you an example. We've done studies with, funny enough, bears, like, black bears and grizzly bears. And when we've analyzed their fiber, even when we equate for size, they're 2.5 to 10 times stronger than a human. They're just the contractile properties, which I can get into if you want, but they just produce a lot more force. And by the way, they have another subset of fiber types that are even faster than our fastest subset. So you combine those two together. Oh, and then by the way, they're massive. I biopsied some people who were elite powerlifters and things like that, and their fibers are massive and super strong. So it can be at the level of the muscles, not all neurological, although that's often what people say. It's partially true, but there's a lot of other stuff going on.